Hello, good afternoon. It's time to start. So today we're gonna go to lecture or lab number 8 for the modeling component of this course, modeling analysis of manufacturing systems. And this is going to be connected to lab number 7, in which we introduce schedules, specifically for modeling arrivals that are not constant throughout the day. We've been using probability distributions so far to capture the variability in the arrival process. But last time we brought the example in which that variability can also change in terms of the pattern by itself, not only in terms of the distribution that you're observing for the arrival process, but maybe the mean number of arrivals that you're seeing during the day may change. So using the schedules can help us model those arrival patterns that are not consistent throughout the day. So this could be examples like you're modeling a restaurant, you're gonna have certain times of the day in which you're gonna see more people. Same thing if you go to the airport or if you are producing in a manufacturing facility, there'll be times of the year in which you will observe more orders depending on the type of product that you're producing. Or maybe through the week or during the day, you might have processes that are higher demand at certain points of the day. So that's the idea. That's what we did last time. Today we're gonna extend that topic to cover the schedules for the resources. So now, in addition to changing the arrival pattern for the day, we know that in practice, you might have different shifts running during the day, or you might have a certain point of the day have some multiple machines running, then later in the day, you might not need to run all of them. Or if we are talking about staff members, most of the time, if you're running an 8-hour shift, you need to provide breaks for your staff, lunch breaks or dinner time or bathroom breaks and so on. So those are the type of things that we can also model with the schedules. You can basically change the capacity of your resource according to your needs, and then you can assess the impact of having those different schedules on your performance. So that can help you also plan for your day and also try to find the best combination. Let's say if you have multiple staff members that need to take a lunch break, how can you stack them in a way that you can continue to run your process and be efficient? So that's the idea for today's lab, lab number 8. So we are getting close to the end of the semester. We are on the second lab for April. I think we're gonna do 1 or probably 2 more, depending on the timeline. And then at some point, you're gonna be presenting your projects, and that'll be the end of the semester. So, any questions? What we're gonna do this afternoon? So as always, make sure that you remember to save your work. As soon as you get into Arena, make sure that you save your file, and that you're placing that file somewhere that you can find it later. And we'll go straight to the new material. So this time, we are going to be dealing mostly with the resource part, here's the schedule component. So last time we talked about the different type of schedules. So we first started with that first bullet. Today we're gonna look at the second bullet, which is allows you to define the resource capacity. And I think I have right here. So this is the goal for today. We're gonna set up these schedules to allow us to define resource capacity based on daily time or a calendar. So the capacity of a resource changes according to that schedule. And you can define as many schedules as you need. Like if you have 10 different staff members with different schedules, you can define a schedule for each one of them individually. And then once you have those schedules defined, you can link them to the right resource in your model. So when we are looking at the parameters for a schedule, today we are going to, instead of looking at the arrival, we're going to be looking at the capacity of a resource. And as we noticed, there's going to be in a previous lecture, we talk about the time frame. So we can determine those time periods according to our needs. So it can go as slow as 15 minutes. And you can be looking at 30 minutes, an hour, and so on. So you can define the time periods that you are going to be using for your resource. I also mentioned last time that we used to have a graphical rate editing component that is no longer available in the newest version of Arena, but I still bring those because I think this visual is helpful in understanding what we are trying to do. So as you can see here, what we have is a graph that is showing a timeline at the bottom in the x-axis. And then you have the capacity in the y-axis. So in this case, that y-axis is showing the capacity of your resource. And this is most likely for a resource that has parallel or station that has a parallel machine type of design in which all resources are the same or they behave in the same way. So you can adapt the capacity and you can go, in this case, goes from 1 up to 6 throughout the day. And in this case, we are defining each bar is representing 1 hour. So something that we need to define as a modeler is what you're going to be using as your time zero. So this could be defined by you as a modeler. You can decide that time zero is 12 a.m. or midnight, or you can start assuming that this is something else, like 8 o'clock in the morning. The idea is once you make a decision in what you're going to be using as time zero, you need to be consistent for the rest of the things that you're going to put into your model. So most of the time, we try to use time zero as 12 a.m., but that's not a requirement. You can choose your time zero, 8 o'clock, 12 p.m. in the afternoon, but you always have to remember, since you're using that as your time zero, that the rest of the model has to follow that same timeline. So in this case, we have an hourly schedule here showing 24 hours from time zero, 24 bars here. And then each bar is showing a different capacity for the first 2 hours. Trying to see if it really meets that. Because first one is 8, the other ones are 3 and 11. I'm trying to remember why is that the case.
I think it's a mistake. I checked it should be 4 and 12.
Okay. So hourly, showing the changes in capacity for the first 2 hours. You got the one, your resource capacity equals 1. Then after 2 hours, you have 3 hours with resource capacity 2. Then it follows to 3 after those 5 hours, and so on. So you can see how those parts are changing throughout the day. And then when you're getting towards the end of the day, it starts to go down. So in our current version of Arena, we don't have this visual interface to play with. But what we're going to see instead of this is a table in which we're going to define the capacity level and the number of time periods that you're going to have that capacity level. Yes, sir.
The capacity is the capacity that we adjust in resources, not the amount of energy that needs to be stored.
Yes. So the capacity is the number of resources that you're going to have in that station during the day.
They're all acting exactly the same. We can.
Yes. So once you define a schedule, it is going to be assigned to a process block. And depending on how many resources you have there, if you have more than one, that means that you're going to have a set of machines that are going to behave the same way. So they're identical. If that's not the case, then what you're going to see is you're going to have a binary type of situation in which you're going to be defining a resource schedule for a single resource that is going to be active, meaning that you go capacity 1. And once you're not active, you goes to 0, right? And then you keep turning on and off that resource. And you will have that schedule assigned to that specific resource that has an independent behavior, basically. Good question. So once you define your schedule, the next thing will be to go back to your resource module and identify the resource that is going to have the schedule. So if you remember from our previous lab, if you click on the resource module, you'll see that by default is going to be defined as a fixed capacity. And then you have a column named capacity next to it. So if we have more than 2 of that resource, assuming that it is an identical resource, you typically will go change that capacity from 1 to 2 or to 3. Or if they were different resources, then we will define them separately. So in this case, we had three different resources. Each one of them will have a different schedule, and then you will go there and you will change that default value for the type from fixed capacity to based on schedule. The next thing that you will see is the software is going to ask you, okay, it's going to be based on schedule to tell me which schedule are you going to be using. And then you are going to define that. So the capacity column will not show up anymore. Once you define that based on schedule, the next thing you will see is what will be the schedule name for that resource. Something else that we need to understand are these 3 rules. So there are 3 things that can happen once you implement these resource schedules. So let me use so these are 3 rules that we need to choose one based on our model or based on the problem that we are studying. So there's three rules that define what you're going to be doing at the time in which you need to change your capacity. So for example, let's say you are you're starting at time 0, and after an hour you go from capacity level 1 to 0. So meaning that you take a break after an hour. So the rules are gonna allow the model to know what will happen if at the time that you get to 1 hour and you're processing a part, what will be the action that you're gonna take? Are you gonna stop and you will complete that part after you come back from your break? Are you going to complete the part and then take the break? And if that's the case, if you complete the part and then take the break, how much time are you going to take once you come back? Let's say you were supposed to take your break at 1, but now you stay another 5 minutes. Are you going to take let's say your break was for 15 minutes. Are you going to take those 15 minutes and come back at 1:20 or after 20 minutes? Or are you just going to take the rest of the 10 minutes and come back at the time that you were supposed to come back? So those are the 3 options that we have. So the first one is called ignore. The resource requires maintenance when finished with an entity and loses downtime based on how long it takes to finish. So for example, a carpenter is making a table. If he has not finished the table by the time his break starts, he must finish it. When he finishes, he may have his break, but must return to work at the scheduled time. His break time may be reduced, right? So this will be ignored. You're basically completing the part, but you're coming back, even though you're supposed to take this long, now you're taking a reduction on your time and you're coming back at the time that you were supposed to. Then we have the wait. The resource requires maintenance when finished with an entity and requires the specified downtime. So in this case, it's the same situation. He has not finished the table by the time his break starts. He must finish it. When he finishes, he may have his break and return to work after his predefined break time. So his break starts later, but lasts as long as it should. So in this case, let's say you're performing maintenance, you wait until the part is completed, but you know the maintenance is gonna take an hour. So there's no way for you to complete the maintenance in less than that time. So the resource will come back after an hour. Doesn't matter at what time you stop to perform that maintenance. And then we have the preempt. The resource requires maintenance immediately and requires the specified downtime. So in this case, say a paint sprayer is spraying a car, suddenly it runs out of paint. The sprayer must immediately be serviced for a specified period of time before it will be operating again. So unable to finish the car it was working on. So in this case, in the preempt, you're stopping whatever you're doing, you take the time, and then you come back and finish after you have completed that, in this case, that maintenance. So 3 rules that we are going to be using to decide or to model how the resource is going to react at the time the break is coming, at the time that you have that reduction in the capacity. Questions? Good. So good. So the rest of the instructions are things that you're familiar with. So these are the statistics. And the statistics for multiple experiments. So let's talk about the example. So this example is representing a 24-hour process in which there are 2 machines. Each one is fed by a arrival process that follows an exponential distribution with a mean rate of 5. And those are split into 50-50%, right? So 50% goes to machine 1 and 50% goes to machine 2. These machines are not identical, so they follow a different processing time. For machine 1, it follows a uniform between 5 and 7 minutes. And machine 2 uses a uniform between 7 and 9 minutes. But there are 3 shifts in this process or this manufacturing facility, the first shift starts at 8 a.m. until 4 p.m. Second shift starts at 4 p.m. till 12 a.m. And the third shift starts from 12 a.m. to 8 a.m. During those three shifts, machine one is going to be running throughout the entire day. And machine two is only running on the first and the third shift. There's routine maintenance is performed on both machines at 5 p.m. and the maintenance takes 30 minutes. Okay, so as you can see, machine one will go down at 5. But machine two, since the maintenance is performed at 5, it will happen during that off time, which we don't have to worry about maintenance time because it's going to happen during that time period in which the machine is down. Okay, so I want to show at the end, after running this, I want to know what are the mean number of parts in the system per day. And we're going to be running this simulation for 10 days per replication. And the number of replications is 10. Okay, so mean number of parts in the system per day, basically looking at the working process. That's what we want to compute. Okay, so let's build this in Arena. So let me switch. Any questions?
There's no multiple machines in this situation, right? It's
No, just 2 machines. Yes. That's a good question. Yes. Because of that maintenance time.
Okay.
So the only way that you will be able to take that machine down or represent that downtime at that specific time period will be by using a schedule. Yes. Good question. Okay, so let's start with saving our model. It looks like my machine. And this is kind of a simple model. I think the challenge is in defining the schedules and the statistics.
Was there any reference to the scheduling rule in the model definition?
That's a good question. So the rules are not stated here. Okay, so we can make a decision based on what we think will be better fit. So there's no details about what the type of process other than there's 2 machines. So I think we can, well, let me just state what I like to happen. So so let's say machines. In this case, if I state that, that means that we are using FreeNet, correct? Okay. So let's start with defining our arrival process. So this is going to use a expo 5 minutes. Okay, so that's our arrival process, follows an exponential distribution with 5 minutes. And after that, since we are collecting the working process, I'm going to have an assign block that is going to define a variable. I'll call it WIP. And the value will be WIP plus 1. And that's the only statistic that we are collecting today, working process. Okay. From there, we are going to split the entities into 2 parts. The default for the decide block is a 2-way by chance, which is 50% and 50%, which is what we want. And then from there, we are going to have 2 machines. All right, so let's go here to process. Process 1, process 2. And for now, I'm not going to edit those 2 because we need to define the schedules. All right, so one thing that we can do is just provide a name for now. So this is going to be a resource. And I'm gonna call this one machine 1. And then we have the processing times, right? So let's also define the processing time for this one. So this one is uniform in minutes, if I'm correct. And this is 5/7.
Second one, please.
So first machine, 5/7. Second machine, sees delay release. I'm going to define the name, machine 2. Also a uniform in minutes, and this one is 7/9. Working process, I'm going to define that WIP. And then I'm going to dispose. So far, so good. We can save. and check our model so far. Check to see if you have any errors. Okay, so with what this is asking for is the mean number of parts in the system per day. Okay. So let's see how can we compute that, because we are going to be running this for 10 days. Okay, so I need to have a separate logic here that is going to be collecting the information for me every day. And what I want is an expression of the WIP. And the tally name is going to be num in system. And what I want is to collect the value of this working process at the end of the day. So for that to happen, I need to generate an entity every 24 hours. And I want that first entity to be generated after 24 hours. So this should be the logic. Logic at the top is representing the system itself. Logic at the bottom is just collecting the working process at the end of the day. Yes.
Would you mind opening up the report, log? Thank you.
Yes, so the value is the value of the WIP and the tally name num in system. Okay. You have a question, sir? Sir, you have a question? Question? Okay, so in the advanced process, we can define the statistic before we get into the schedule. So let's do that. What do we need first? We need an output. And this is gonna be TAVG num in system. Okay, so this is gonna be the average number in system. Okay, so let's get into the schedules. So go to basic process. Inside the basic process template, there should be a module named schedule. In there, we're going to define two schedules. I'm going to call the first one M1 schedule. And the second one, M2 schedule. So based on the information that we have, what will be the time window or the time periods for the first machine? It's gonna be what? Yes, but we need to choose if we're gonna be using time periods of 1 hour or 10 minutes or half an hour. Which, what type of time period do you think will be the one that we need to use for machine one? Yes, but I think what do you say? Half an hour. So because since we need to specify a maintenance of 30 minutes, we need to define our time periods in half an hour. In that way, we can select the time periods that the machine is going to be up. And then when it gets to that half an hour in which the machine is going to be down, we can switch the capacity to 0 only during that time period. If you use time periods of 1 hour, for example, there's no way for you to specify a downtime of half an hour, right? But if you choose 15 minutes, then you can choose 2 time periods of 15 minutes to represent that downtime. So our time periods, the size of the time periods are going to be based on the requirements for that specific resource. So machine one, you need to use half an hour. So under that, we need to specify here the time units, half hours. And then we'll click here for the durations. And here's where we need to specify, or we need to understand what are we going to be using at time 0 as time 0. Are we going to use 12 a.m., 8, 12 p.m., I'm sorry, 4 p.m. So let's go back to the description here. We had 3 shifts. One starts at 8. The second one starts at 4. And the third one starts at 12. So far, we use, if you remember, I did it on purpose, for collecting this statistic, we are saying that we are going to generate our first arrival after 24 hours. So this is okay. We need to be careful. Now, in how are we going to choose this time based on how we're going to be defining those schedules as well. So here, what we are saying is if we start at time 0, the end of the day will be 24 hours. So that can represent multiple things, right? This could be if you start at 8 a.m., that you're going to be running your period, your day until 8 a.m. So the first day will end at 8. Now the question is that what you want to do? Or, I mean, there's no right or wrong answer here. What I want you to understand is if you choose a time 0, you need to make sure that the rest of the model is also consistent. Okay, so I think making 12 a.m. your time 0 is typically your best bet. So it's easier for you to remember. Other than choosing 4 p.m. or 8 a.m., then it can get confusing. So that's what we are going to be doing for this model. We're going to assume that 12 a.m. is going to be your time 0. So at 12, not what we are doing here. We need to know how many half hours are passed until 5 p.m. if you're choosing 12 a.m. as your time zero. I need you to make that computation, right? So 20, 34. So yes, divided by, so how many hours are between 12 and there's 16, 17, right? So 34, right? So 34 time periods until you get to 5. So let's do this. I think it would be better if we split it into 3 shifts. So basically what I'm saying, we're trying to get is the following. So let me add a blank sheet here.
Would it make a difference if we're using for your schedule half hours, but I'm using hours? If I'm,
You cannot use hours because then you will not be able to shut down your machine for half an hour.
so it doesn't take 0.5, it would not take it.
No, it has to be integer. Yes, integer values. Yes, so good question. So what we are saying here is my time zero will be 12 a.m. and trying to get to 5 p.m. because at 5 p.m. I'm gonna have a maintenance, right? So the machine will go capacity 1 all the way here. Then at 5 p.m. it will go down. And then at 5:30, we'll go up again until 12 a.m. So that's my schedule. So how many time periods are from 12 to 5? We said that there are 17 hours, which is equal to 34 half hours. And then this is gonna be 1. And then after that, we get how many hours? From 6 to 12 will be 6 hours. Yes, 6 hours times 2 is 12 plus 1. So it's gonna be 13 half hours. So if you add that up, you get 48, which is what we have for an entire day. So if that's the case, then I'll go here and I specify that number in my schedule. So it's gonna be 1 for 34 time periods. Then it's gonna be 0 for 1. And then it's gonna be 1 for 17, 14, 15. Oh, what did we say? 13, actually. 13, yes. So 1 for 34 time periods, then it goes 0, and then it goes back on for the rest of the day. So that will be for the first one. Okay. Close. For the second one, it's a little bit easier. You go 12 a.m., 8 a.m., then 4 p.m., and 12. And you'll be up, down, up, down. So right?
No, I think that the 4 p.m. to 12 a.m. is the.
Sorry. I'm sorry. Yes, so 8 a.m. to 4 p.m., 4 p.m. it goes down. So, okay, so let me do that here.
Two periods on and 1 period on.
Yes, so I'm trying to find the eraser. Not letting me erase this for some reason. So let's do something else. So let's crash this. We got 12, 8, 4, and 12. So we'll go like this and then go 0. So for this, we can keep the hours. But then we have to define our schedule. So it will be 1 for 8 hours, and again 8, and then will be 0 for the third shift.
Could it be 1 of 16 hours there?
Yes, that could work too. So it'll be 16. Yes, sir.
So if I choose a different point of start, but I'm keeping things consistent, are the results supposed to be exactly the same result?
Should be, if not the same, very, very close. Yes. The one thing that I want you to remember is that you cannot forget, like in this case, you have 16 time periods with 1 and then 0. You had to put the 0, even though it's not in between the hours. If you don't do that, what Arena is going to do is going to repeat the 16 hours. Once the schedule is completed, it will start again with that schedule. If you don't put that 0 there, it will assume that you're going to end that schedule and you're going to repeat it again and again. So instead of running for 24 hours, we'll run 16 and then 16 and then 16 again. So the 0 capacity for 8 hours has to be there. So Arena knows, okay, after the 16, we go to 0 and then we start again.
So that means 8 hours. Oh, okay.
No, nothing is going to be processed by that machine. So you generate the queue basically, and it will start again once the machine goes off. Good. So we have defined those 2 schedules. Now we need to go to the resource module. And if you click on that resource module, you are going to change from fixed capacity to based on schedule. And in here, you see in yellow, it's going to ask you to select the schedule. So for machine 1, we are using schedule 1 or M1 schedule. And then here's the schedule rule. So we said that maintenance is going to be performed immediately, which means that you're not waiting. We are going to preempt. Okay. So let's do the same thing for the second machine. This is gonna be based on schedule. And 2. And then preempt. For machine 2, it's not gonna make a difference because the maintenance is happening during the time period. However, if you think a little bit more about machine 2, we are taking that machine down not for maintenance. We are taking that machine down because you are finishing your schedule. So it's a different situation, right? It's not necessarily you're shutting down the machine for maintenance. You're shutting down the machine because you're ending the schedule for 8 hours. So this might not be the rule that you want to use, right? You don't want a part sitting there for 8 hours and then whoever's coming back for the next shift have to deal with that part that has not been completed. So in this case, you want to choose something else, right? So the difference between wait and ignore is you're coming back, right? You're coming back. Are you coming back after you're taking your time off completely? Or are you coming back just taking the time left? Again, in this particular case, doesn't matter. It's not gonna make a difference. But if you were taking a short break, like bathroom break, lunchtime, it would make a difference. So we want to choose, we can choose wait or ignore. So I'm gonna choose wait because in this case, it's not gonna make a difference. Wait.
Would it make a difference? Is it if you're pushing the time?
Yes. Now that I'm thinking about it, yes. So it's gonna push the 8 hours, right? So you want to come back exactly at the beginning of your schedule. So in that case, yes, thank you. It will be, you're gonna ignore, right? You're gonna come back exactly at the time. So you finish the part and then you come back at the time of the beginning of the schedule. So you see, yes, this is a good example to illustrate when to use which one of these rules. Yes.
So in this example, we have 2 machines and one of them has a third availability more, but we're splitting the entities equally.
Yes.
This is, especially over a long period of time, a great way to crash your simulation. And what is like a?
Yes. So the question is, we are running this for, we are splitting the parts independently of whether they're available or not, right? So I would say that's not necessarily what's going to happen in practice, unless you need a process that needs to build some type of working process to be ready when the shift that is coming after 8 hours needs to have that type of work in process ready to continue. So we didn't get into those details for this particular example, but I understand what you're saying. If you're worried about the model crashing, that's not gonna happen for this model, even though we have the student version of the model. Yes. Any other question? Good. So let's see what else. So we got everything defined. Okay. So we need to set up the experiments. So please save your model, check for errors. Let me know if you have any errors. If not, let's go to setup. So we are running this for 10 replications, and the replication is 10 days. And the base time minutes are minutes. And then the project parameters, I'm going to uncheck all this. Then apply. And for the reports, I'm going to use the Simon. Okay, so let's see how that goes. You got the same?
Yeah, I've been getting a bunch of crashing.
No error in the model, but.
So I guess what you're saying is creating that process that is not active is creating a big queue, and we can see that with the animation. Let's see.
In the first day, you'll have like 80 or 90 entities waiting for machine two, whenever you have a job. Also the capacity for them.
So yes, so at that point, let's see at what point it crashes. So at the end of the day is when it goes down. Oh, so it's 10 days, right? So I don't see why it's not. It went to day number 2 already.
Cleaning out the queue at machine two between days.
You see here saying that we are in 60, 69, 70.
Like 150, then it crashes.
Yes.
Still running.
So it happens on a particular day then, right? We're in Wednesday right now. So when it gets to towards the end of the week, I think is where we are seeing the problem. So we can, yeah, that's a limitation of the, as you said, the student version. So let's see if we switch from 10 days to 5 days, see if that works better. No? Mhm. Interesting. So I think we need to be more creative then. Let's increase the arrival process. Maybe, let's see if we make it constant. Okay. So what would you suggest? You got a high output. Did you change the model? No, you got it?
What if you changed the side block to make it into a smaller portion of the entities would go into machine two?
Right.
So,
80%.
Let's try 70 and see how that goes. Yep. So 70 is good. Let's see if I go little down. If I do 60, yeah, even with 60 is running. So if you put 60% in your design block, it should run. And yeah, but the good thing is that you were able to see what's going to happen given the limitations, and you understand why we are getting that error, right? Because we have a limitation in the software that is not allowing us to have more than 150 entities. So by shutting down a machine that's still getting parts, you're building this huge amount of units in front of that machine, which is going to have more entities than the one that the software can handle. So if we split instead of doing 50 and 50, we send more parts to machine one, which is running almost the entire time. We are not going to build that queue in front of machine two. You're still building a queue, but not as big as 150, so we can get a result. Okay, so what I'm getting here is 43.44 working process in our system. Did you get something else? You got 21. That's kind of half of it. So what did you do differently?
I set the starting time at 8 a.m.
Yeah, that makes sense because since we are collecting at the end of the day. Right now we are collecting when the second machine is down, right? So that means that you have a big queue.
You're collecting it whenever.
Yeah, I'm collecting at the end. I'm collecting at the end of the day when basically at the end of the shift of machine two being down. So I would expect to have a higher working process in my system, whereas you are collecting when machine two is running, I think.
Correct.
So you would have a lower set of parts inside the system. Okay. So in that particular scenario, it makes sense. Makes sense. Good. Questions? See, we're getting to that area of the modeling in which small things can make a difference, right? And that typically is what's going to happen in practice, right? You need to make sure that you're designing your model under certain conditions and you're testing your model under those conditions, because those small details can make a huge impact in the results that you're representing in the machine. You know, the actual process is not going to change, but when you're building a model, if you are not taking into account those factors that are relevant from your system and modeling the right way inside the computer, those small changes can make an impact in the results that you're going to observe, and they're going to be different from what you're observing in the real scenario. Good. So questions? As I said in the previous lecture, you should be working on your project in terms of representing your system, building that arena model in a computer, inputting the input values that you got in your second report are graded. The report, I posted the grades. I noticed that there were some of you that were not getting the p-values for all of the distributions. So if you are able to collect more information from your system and make sure that those values are higher, so you can be sure that the data that you're collecting is I mean, you get a probability distribution that is fitting the process that you're observing. I would recommend that. Also, some of the reports were not showing a table with the historical data in terms of the values that you're gonna be using for validation. So make sure that you have a table that shows, okay, this is the average cycle time from the system. This is the average throughput for my system during this time period. So when you build a model, you can check if your model is getting close to those numbers. So we can validate the model. Yes.
So when I use the interval time in second, it gives an exponential distribution. But when I use the same interval time in minutes, then it's showing uniform distribution. So is this okay?
So
Sorry, wait a second.
no, I understand what you're saying. So if you're using time units to fit the distribution, let's say in seconds, the probability distribution that you're getting is also based on those time periods, right? So when you are inputting that distribution in your model, it has to be in seconds, okay? As long as you're consistent with the time units, you should be okay. Okay, but what I'm trying to say is, yes, is you're observing, you might be getting a different distribution because the shape of the histogram will change. And then when you're looking at seconds, you get a shape that is more consistent with a probability distribution. So when you're using that information to your model, you need to make sure that the time units are consistent because it is based on those time units. It doesn't mean that they're giving you it's giving you two different things. Like they're representing the same system. The only thing is your observations in seconds will be, they fit a different distribution, right? But they are still representing the process that you observe. Yes.
So I can use either one of the distributions, just putting the time.
Yes. So as long as if both of them are good in terms of the p-values, you can use either one, but just make sure that you use the time units that you use to fit the probability in your model. Okay. Any other questions? Okay, if not, then I'll stop here. We'll meet again on Wednesday. And yeah, on Wednesday, let's say next Monday, I will have some time to ask questions about your model for the project. So we are gonna cover Lab 9, but we also gonna spend some time checking on your models. So if you have a preliminary model ready, it will be good. So I can give you some feedback before you submit the project presentations and so on. Okay, so if you don't have questions, then I'll see you Wednesday.